The data world would be more advanced if people applied more software engineering practices to it. Things like deployments, checks, testing, all those kind of stuff. A lot of people in data, they might not have a software engineering background, but building a good data pipeline is very similar to building good software. Your data modeling abilities and how you structure things is the most important part. And that's probably only getting worse with the advent of AI and LLMs.
You're listening to Data Renegades, a regular series where we discuss data, code, culture, and everything in between. We interview pioneers of tools and concepts we now use every day in the data world. These ideas often started as experimental projects or unconventional approaches. The builders are renegades who are inspiring and shaping the industry. Data Renegades is brought to you by Heavybit, the leading investor in enterprise infrastructure. For more information, visit heavybit.com. If you're interested in being a guest on the show, or if you would like to suggest a topic, find us on datarenegades.com.
Hi, I'm Dori Wilson, Head of Growth and Data at Recce. Welcome to another episode of Data Renegades.
And I'm CL, CEO and founder of Recce, and your co-host. Today, our guest is Toby Mao. Toby is the creator of SQLGlot and co-creator of SQLMesh, two open source projects that have changed how the data industry think about SQL. He built them into Toby Data, which was acquired by Fivetran last year. Before that, he led data infrastructure at Airbnb and Netflix. He's also a former Rubik's Cube world record holder who once taught Will Smith how to solve a cube for a movie, The Pursuit of Happiness. Hello, Toby. Welcome to the podcast.
Hey, thanks for having me.
Yeah, it's good to have you. So let's dive into your involvement in data. Can you take us back to the beginning, kind of what problem first pulled you into the data space?
Yeah, so that's kind of a long story, but I graduated with a degree in math, kind of was looking for whatever company would hire me. Ended up landing at a pharmaceutical consulting company called Begu Consulting. And that's kind of where I got my first foray into data programming and data analysis. So at that company, I was mostly using SAS and Excel and basically crunching pharmaceutical numbers like prescriptions and sales data. And I actually enjoyed SAS a lot. I enjoyed crunching numbers and building reports and all that kind of stuff. Eventually, I got tired of that and decided I wanted to become a real software developer. So I spent a little bit of time doing iOS, and then I managed to land a job at Scribd, kind of like documents and ebooks online. And I started to do Spark there. I started working on recommendation systems. And so that's kind of how I got into big data. And then from there, I went to Netflix, Airbnb, and then started Toby Data.
How do you feel your consulting background initially, played into your later roles?
I'm not sure, but working with clients, they have needs, right? And you kind of learn how to talk to them and how to have relationships with them and building stuff for them. And so I think that has definitely helped me later in the career because it's not just about your technical skills, right? It's also about dealing with customers and sales.
Yeah, definitely sales.
Yeah.
I think I've heard at the larger companies, my own experience, internal sales can be another way of talking with stakeholders, pitching them on different ideas.
Yeah, exactly. And so at Netflix and Airbnb, I did a lot of internal sales. And so starting my own company, trying to sell a SaaS product was honestly very similar, right? The experience of technical selling was very relatable. I think the biggest difference is just that you don't have the same kind of political motivations or internal alignment that makes things easier internally versus externally.
Oh, interesting.
Okay, so you start as studied math and then going to consulting and then wanted to do more software side, right? And then going to this big companies, figuring out the internal data infrastructure. So what was the spark that you kind of launch ideas around SQLGlot and SQLMesh?
So when I was at Netflix, I worked on the experimentation platform, and that revolved around data scientists basically adding queries to the metrics repository. And that was mostly SQL. But at Netflix, right, they have unimaginably large data. They also have multiple engines, right? They use Spark, they use Trino, they use Druid, and all of these engines have very different dialects, right? Even though there's a SQL standard, nobody really adheres to that, and everybody has their own implementation. So when I was at Netflix, at the time, there weren't any real good solutions, and so I used a library called PyPika. PyPika is kind of like a Python SQL builder, and I extended that to do transpilation so that they could use PyPika and we could then compile the Python code into Trino SQL or Spark SQL. Towards the end of my tenure there, I realized that data scientists don't want to write Python. It's hard, right? They want to just write SQL. But there was no way to parse a Spark query and then run that in Trino. And so that's kind of where I got the idea for SQLGlot, building a SQL parser and transpiler so that you could write SQL in one dialect and run it in a different one.
That's cool. So you built that out internally then?
Yeah.
What was something that building it out internally that you found different, easier, or harder than when you went and started to be good data?
I built it as a kind of side project, and then I later decided to go to Airbnb, and they had a very similar problem, right? They also use Trino and Spark, amongst other engines, and so I decided to leverage SQLGlot when I was at Airbnb, and that gave it a lot more use cases and made the product more mature. And so it was nice because I could kind of just use it because it was fully open source. And it basically got automatic adoption, right? I had a great use case for it, and it drastically improved both the platforms I was working on and SQLGlot itself.
So it's almost like you're getting to do some early design partner refinement at another company.
Yeah, exactly. And then, around that time as well, other companies started using SQLGlot heavily, like Google, etc. And so the project started having more traction.
And that's because you had made it open source, right? You had already had it available.
Yeah, SQLGlot has always been MIT licensed.
So you kind of feel like kind of the PNF tool internally for adopting that across different companies, right? And then, but like SQLMesh tries to solve a slightly different, I guess downstream problem where the actual user has kind of daily use of like managing those queries. So how does that like manifest into its own product?
Yeah, so SQLMesh is a little bit of a higher level tool than SQLGlot, right? So SQLGlot is just a parser, transpiler, and SQL general framework. But in terms of running DAGs and scheduling and understanding what has changed, that's where SQLMesh has come in. And so SQLMesh is really a full transformation tool that lets you run SQL or Python code.
So yeah, when I had my hands on SQLMesh, I really felt it's like really well designed for like item potency, and then like, but I can see that where it's coming from. Like it's pure function, like mathematics, right?
Yeah, right. Yeah. So at companies like Netflix and Airbnb, there's a lot of data, right? Processing huge amounts of data. And so doing things like full refreshing your data every day just doesn't really work. And so all these companies kind of have date-based or batch-based processing, where you process incrementally one day or maybe a week of data at a time. But it's done in a very parallelizable way and done incrementally. And so I wanted to kind of build a framework, a transformation framework that first class kind of tracks state, understood time, and all these kind of things. And being a software engineer who works on data platforms, right? I wanted to bring software engineering best practices to data, right? Things like deployments, checks, testing, all those kind of stuff.
So I feel we've been down this like a trend of like bringing software engineering best practice to data for I guess at least 5 years now, right? And then you are on kind of like the deepest level, like the SQL transpiler, and then also the orchestration level, working with actual like data consumers and authors. So what do you think is still the hardest problem of data engineering today that nobody's really talked about or tackled properly?
Well, I think at the end of the day, your data modeling abilities and how you structure things is the most important part. And that's probably only getting worse with the advent of a reliance of AI and LLMs, right? I myself have been using AI very heavily the last couple months, and it's been great. But I can see how it's a tool that benefits people who know what they're doing, and kind of, although it enables people who might not know things like architecture and data modeling as well, and it can like let them be productive. I'm curious about what the long-term impact of that will look like in the next couple years.
What have you found it to be most useful for?
So my team at Fivetran has been highly leveraging Claude to refactor SQLGlot. So SQLGlot is a pure Python library, and that's the design goal, right? I wanted to be Python, no dependency, so that any data scientist or analyst can install it, run it. It's easy, right? But Python is not the fastest programming language, as everybody knows, right? And so, it's honestly not that important for it to be fast because it's fast enough. Because the bottleneck for a data pipeline isn't the SQL parsing, right? It takes, I don't know, a couple milliseconds to do that. And it takes seconds, maybe minutes or hours to run your SQL queries. But when you're parsing, a lot of SQL, it can add up. And also people like things to be fast, right? It's kind of
Mm-hmm.
a hot marketing topic, right? Everyone wants to rewrite stuff in Rust.
Yep.
And so I had the idea in January to leverage MyPyC. So MyPyC is run by the folks who do MyPy, the Python type checker. And it is a very cool project. It takes normal Python code that has been annotated, and it can compile that into C code, right? C code that leverages the Python C API. And so what that effectively means is you can get anywhere from like a 2 to 5x speed bonus just by having proper types.
Wow.
And so we've been using Claude to refactor SQLGlot to be fully type annotated and to compile with MyPyC. And it's an exciting day because today is the day that we're going to release V30 of SQLGlot. And it is now, up to 5 times faster than the previous version, which was written in Rust.
Congratulations. That's got to feel incredible.
Thank you. It's so exciting, right? And not only did we get rid of Rust, right, simplifying the build process, now we have a pure Python library that can compile to C. That is arguably one of the fastest, packages in the Python ecosystem. It is comparable to pure Rust libraries that have Python wrappers. So it's super exciting.
Yeah. Could it be used for other things as well? Like how applicable could that be?
Yeah.
Like I guess more agnostic than your use case.
So MyPyC can be used for any Python code that's typed. But AI was really, really helpful here because, first of all, SQLGlot has thousands of tests, a ton of tests of all these different crazy edge cases. And so the LLM can refactor very well because it's not trying to do anything new, right? It's not trying to create something brand new and novel. It's simply reorganizing things that are very tedious for the humans, but it's very good at. And because there's so many tests, every step of the way, it's able to check itself, iterate, and figure out exactly what to do.
Yeah.
And, I didn't really use AI too much before January, but I think after January, something really changed with the model. I think the agents got a lot better. And so I had these ideas to do MyPyC, right? But I wasn't sure which one would be the right idea. And so with Claude, while watching Netflix, I was able to try 10 different things. I said, hey, try this, try this, try this. And 9 of the 10 things I tried weren't faster. But on the 10th attempt, while watching my cooking show, I was able to get significant speed ups, right? And so I think that's kind of the real power of it is like, I was still giving it ideas. I was still directing it, but it was handling all the coding. And I was able to do that because it was a well-defined refactoring problem
Yep.
with thousands and thousands of test cases.
Yeah. So when you say well-defined, were you using skills, workflows? Like how did you make sure that the LLM didn't go off track too much?
Yeah, that's an interesting thing. So I don't really use any of that stuff.
Ooh.
I just tell it what to do. And I think my kind of talking style really translates well to it because I tell it exactly what to do. And so I don't give it open-ended problems. I try to break it down for the LLM and I say, hey, let's do this first, right? And then only once I'm satisfied with that one step do I move forward, right? Because there's noise, right? Whenever an LLM does something, it doesn't do it perfectly. And if you keep just compounding off that, it gets worse and worse. And so I basically have the LLM do one thing at a time, and then I review its code as rigorously as I would a human.
Yeah.
And so that's kind of my workflow.
So extensive planning and then a deep dive in the kind of the review stage.
Not even that much planning, right? I do more iterations. Like I'll try different things. And when I'm satisfied with a particular approach, then I'll do full implementation, benchmarking it, reviewing it, and then going on to the next step. So honestly, I don't really leverage planning that much.
Fascinating. But it sounds like you have it's almost like truly you are doing the planning itself because you have each stage and doing that iterative process of like until it gets there.
That's right. I obviously have a strong intuition for how SQLGlot is architected because I wrote it. And I'm leveraging that to basically guide the LLM. But I do ask the LLM for tips as well, right? I might not necessarily know what to do, and so I'll ask it for different options. One of the cool things that we've been doing is that MyPyC is still, it might be labeled alpha, I'm not sure, but it doesn't work perfectly, right? And we've created 7 or 8 PRs on MyPyC, which have been merged pretty quickly. Kudos to them.
Yeah.
But we were able to fix MyPyC bugs with the LLM, even though we've never used MyPyC before, right? And so that was really cool.
Yeah, I'm definitely hearing a lot from like very experienced software engineer like leveraging AI in different ways, and then like all sounds really amazing in the past few months. But like, what are your thoughts about how that kind of translate to like data work? As in, like the work you talk about is really like deep in the transpiler with well-defined tests, and then also maybe patching upstream like MyPyC. But what happens to like applying AI to like data work? We touched on that. You think there's gonna be like maybe some slop generated, or like how do you feel that it will work in real world like data work?
Yeah, it's interesting. I think that data is interesting because the consequence of running a query is higher than running a unit test, right? Because you have real world cost with BigQuery or Snowflake, especially if you have a lot of data, and time. I think AI's optimizing that workflow is all about decreasing the loop time, right? So you want your test to be fast. You want it to fail fast and get results. But if every time you run a query, it takes minutes, it can slow things down, and it can also cost you a lot of money. And so I think in order to kind of improve the AI flow in data, you really need to figure out how to make that iteration cycle cheaper, both from a time and money perspective.
To shift gears a little bit, what is the hardest part of data engineering today that no one's talking about?
It's probably always just the data modeling, right? Figuring out the best way to structure your data to make it so that change is easy, right? I think that data from a lot of companies is a big advantage, right? And especially with AI becoming more prevalent and AI thriving with more context and more data, having a data pipeline that can grow with your business is very important. And so I think a lot of people in data, they might not have a software engineering background, right? But building a good data pipeline is very similar to building good software, right? Understanding high-level flows, architecting it in a way that changes aren't breaking or that changes aren't very difficult to make. These are all things that I think have very similar pattern recognition to software, building good software.
I think you touch on like how to kind of plan things that's easy to change. I feel this is like a underappreciated thing that because a lot of the time that things are built kind of one off. So what are your thoughts on like making that a more accessible, approachable kind of mantra for people building out things that's ready for more changes coming?
I think maybe the first part is less is more, right? If you have fewer things, fewer models, and fewer dependencies, then the changes will obviously be less because there's less stuff to change.
Mm.
If you've got an intertwined spider DAG where everything depends on everything, when you make a change, of course, you're going to have to change a million things.
Yep.
I guess tying this back to AI once more is like AI is very good at one shots. Like if you give it a problem, it can solve it, but it might solve it in a really ugly, hacky way, right? I don't think at this stage AI can really make maintainable decisions, right? There's actually an interesting study done, like the software engineering CI benchmark, and it showed that with a different kind of metric for AI competency, what it did was it took like existing open source repos and instead of one-shotting problems for the LLM to solve, it would like use its solution and have it face the consequence of those solutions, right?
Ooh.
And so it would then go on to the next step. And over the course of like 1 or 2 years in the experiment, it would be like, okay, how many bugs have you introduced because of your previous decisions compared to the original source code? And it showed that even the best models today still introduce bugs, 1 out of every 4 commits, right?
Ooh.
And so it's still not really there yet to do long-term architectural planning. And so I think that kind of skill set is something that experienced developers kind of grow an intuition for. And generally, it's just things like doing less, keeping things dry, right? Don't repeat yourself, and understanding your data, how your industry could possibly change, and architecting for that. I know it's kind of vague, but this is kind of an art form.
Yeah. No, it makes sense. I've had it where the LLM, instead of using an out-of-the-box test that's baked into like dbt utils, created it as a macro, which is just adding a point of failure that is so unnecessary into my repo and my workflows.
Exactly.
So just to reiterate, I think it's like no code is the best code, or fewer code better, right?
Mm-hmm.
And you talk about like do not repeat yourself, all this kind of best practice. I find myself like just telling the LM that do not over engineer, and then you ain't gonna need it until that thing is actually needed. That's also helpful. Okay, so I wanted to you work on like data big like infrastructure in large companies, and then I wanted to ask like what's kind of the most painful bug or failure you've seen in production that you can talk about?
I guess an interesting story was when I first started at Netflix, I joined the streaming experimentation team. So the streaming platform is kind of how you watch shows. And then experimentation is basically testing if different encodings causes the stream to be smoother, stuff like that.
Yeah.
And you can imagine that the streaming data set at Netflix is one of the largest streams, right? Lots of people watching Netflix all at once. And every second or more, you're getting millions of requests, right? And so analyzing all that data is very difficult. Netflix is an interesting company because they really believe in data. They are very data driven, and every single decision is data driven. And when I first got there, their experimentation platform, it took like a week to crunch all the numbers and provide results for a given test, which is insane, right?
Yeah.
And half of the time, I think it failed too. So you'd have to restart the job. And so it was very expensive, and it was also all done in Hive. Hive was a older,
Older big data, yeah.
MapReduce kind of SQL code, older tool, right?
Yeah.
Spark at that time was gaining popularity, and I was like, hey, why don't we use Spark for this? And so over the course of a couple weeks, I was able to kind of restructure the Hive code into Spark jobs. And instead of taking 1 week, I was able to get an experiment to compute in about an hour. Obviously, I had access to 4,000 cores, but still, 1 hour is much better than 7 days.
Yeah.
So that was kind of a fun and exciting thing that I did in my early days at Netflix.
A curiosity as somebody who worked on a video infrastructure product, how much of the experimentation was done on the video quality itself?
Oh, yeah. The video quality team are one of the top experimenters, right? Because how can you really understand the changes across every single possible network, across every single possible device. And so whenever they would make changes, they would test everything. They did even have like offline tests where they use simulators.
Cool.
So I would say that they're very, very rigorous. And that's why when you use Netflix, it's great. Like it's so fast and it's just snappy compared to other streaming services, which buffer for a long time.
Oh, yeah. Well, and even when the player first starts up, like that low resolution, sometimes you don't even have that initial loading thing.
Yeah, it's amazing.
Yeah. A question, since you've had, big experience consulting and then building your own company, I'm assuming smaller, more mid-sized teams. What is something that you have seen across all these organizations that is like a similar problem? And what do you think is something that becomes more of an issue as you grow?
So I think that when I started Tobiko, my experience at the big companies definitely set me up for a disadvantage because my team were all former FANG engineers. So we kind of came at it with the mentality that everyone had big data problems. Everyone's using Spark and Airflow, and that's just not the reality, right? That's the 1% or 0.1%.
Yeah.
Most people out there, most companies, they just use Snowflake. They just use BigQuery, and they barely have any data.
Relatively speaking.
Relatively,
Yeah.
right?
I think for our listeners, relatively.
Yeah. And so I think that after talking to customers, we quickly realized that, yeah, not everybody needs to process a petabyte of data every day.
Yeah.
And so knowing that, we kind of moved away from things like Airflow and into making integrations with BigQuery and Snowflake easier and more seamless, right?
Mm.
And so I think that was kind of an interesting framing shift that we had to do very quickly.
Yeah.
Okay, so you've actually built quite a lot of things, right? But kind of like the entire data stack, if you were to kind of rebuild one piece of the stack from scratch, well, what would it be now?
I'm not sure. Given that AI is hot, maybe something there. Another area that I'm interested in is like a new UI for data, right? I think that over time, as the LLMs get better at generating code, writing SQL or writing Python code directly might not be as important as understanding what's going on, right?
Yeah.
So, for example, you might not need to see the assembly, the machine code, right? You want something higher level. And so similarly, like I'm interested in like how can we design UX such that a human can guide and understand what the LLM is doing efficiently without having to dig into the nitty-gritty. So that's something that I've been playing around with, like visualizations of real-time data, updates, how they affect things, where the bottlenecks are, and that kind of area.
Okay, so kind of new type of like UX enabled by AI, working with data.
Yeah, as a simple example, right? Data diff, right?
Yeah.
When I change the SQL query, what does that do? How does that change the data? I want to see it, right?
Yeah.
If I look at two SQL queries side by side, I'm like, okay, whatever. But if there's like a huge CTE, how do I know how that affects things? But for example, if you had a data diff, you'd be able to be like, oh, okay, this value changed, right? And so I could then leverage that to then iterate more.
Yeah. I think that's for me, and I'm curious your thoughts here. A big difference between data analytics engineering and software engineering is the output matters so much more than the actual code itself.
Right. Sure.
Okay, so we're gonna like we touched on AI a lot, right? And then you being like, I guess experimenting with a lot of things with AI, and then for like if you fast forward 5 years, what do you feel is gonna be like laughably outdated about how we deal with data today?
Honestly, I don't know, right? I think that maybe we've hit a local maxima and things will be like this with improvements or things will get significantly more advanced. I'm not sure, right? Things are moving quickly and there's still a lot of uncertainty there. But I think with the way things are trending, right? I think that directly writing code won't necessarily be as important. But I still think that architecture, understanding flows, and guidance are still going to be important. So I think that in the next 5 years, we will see a difference in how people interact and develop code, right? I think that it's more going to be based on these text interfaces or even voice.
Yeah.
And the systems for dealing with them is more going to be around, displays and real-time kind of feedback of what's going on and how to optimize that.
Yeah. If you were starting out earlier in your career, what would you recommend that, more junior analytics engineers, maybe new grads should be thinking about and working on?
It's so hard to say. I think it's a whole new world, right? And so for the juniors out there, I think it's a very interesting time. I would say that the fundamentals are still important because as of today, in order to be effective with LLMs, you still need to guide it. You still need to heavily code review it, right? And so I think that the most important skill is reading code and understanding it and understanding how to improve it. I also think that given the tools these days, it's so much easier to learn, right? Because you don't have to just Google things anymore and hope that someone on Stack Overflow 7 years ago had the exact same problem you did, right? Now you can kind of ask the LLM how to do things. And so I would suggest that for people coming into this to leverage the LLMs as a teacher. So you shouldn't rely on the LLM to do everything for you. Instead, you should use it as like an ultimate guide and have that improve your knowledge so that you can then use your intuition and knowledge to guide it to build the best thing.
And then for mid-level and senior level, what advice would you have? Is the same thing?
So for mid and senior, right, I think that leveraging your experience reviewing and architecting these is even more valuable now. And so don't get lazy is my suggestion. Don't just accept whatever it builds for you. You should always challenge it and be ruthless with your reviews. So these productivity gains, if you want to always improve, you shouldn't be satisfied with them. You should use them to do more than you would have before. You should be doing more benchmarking. You should be doing more variations to find the best. And so, sadly, these days, I've been working more, right?
Yeah.
It's good for the capitalists out there, but bad for my mental health, right? But effectively, I wasn't coding that much before. Like prior to January, I was mostly in meetings, sales calls, talking to the team.
Yeah.
But because I still have ideas, I still know what I want to do. Now that I can tell my LLM to do it, now it's like, oh, wow, now I'm also coding, right?
You just added it back in.
Yeah. So, yeah, it's like a double-edged sword. The good thing for me, though, is like coding has always been my hobby, making stuff. And so, yeah, I'm doing more now, but I'm able to do it because it's so much fun for me. Like, it's just like a hobby of mine.
Yeah.
I can totally resonate. I'm coding more. So, okay, what's going on?
Right.
It's definitely the most lines of code I've quote unquote written. And especially like before it was like Python, SQL. And now with Claude, it's like I have so many side projects I just have going in languages I do not understand, which pro con can't catch the silly bugs that I can when it's writing SQL or Python, but I can create stuff that I definitely could not have before and certainly faster than if I had tried to struggle through. Is there a side project that you're working on unrelated to work?
Not currently, no.
Full plate.
Yeah, I think you had like board game like side project before and stuff, right?
Oh, yeah. Yeah, that's still ongoing. So back during COVID, I created a website called 18xx.games. It's basically a platform to play hardcore economic train games.
Ooh.
Yeah, and so that's still going strong. I don't really contribute to it anymore. I have many open source contributors, and I know that's still going well, but I don't really contribute to it day to day.
Yeah.
Okay. Before we wrap, we're gonna put you in like data debug round. So we're gonna do a couple of like quick fire questions and then just short answer. You ready?
Yep.
Okay, cool. First programming language you love or hated?
I guess I liked Objective-C.
Ooh.
I had fun with that back in the day. The one I hated was VBA. I hated VBA.
Excel shout out for those that don't know what that is. Horrible, horrible language. Okay, next question. What is your go-to data set for testing?
It depends on what I'm doing. If it's like SQL parsing, I use TPCH. If it's for the actual data, I don't have a go-to data set. I just use whatever I have at work.
Pure production data. Love it. What's one lesson from outside tech that influences how you build?
If you have fun doing something, it's not work. And you do better when things are fun.
Okay. What's one hot take about data you're willing to defend on podcast?
The data world would be more advanced if people applied more software engineering practices to it.
What's your favorite podcast or book that's not about data or tech?
My wife has a board game podcast called Board Game Blitz.
Ooh. Wait, what's your favorite board game?
It depends on who I'm playing with.
Oh, I love it.
Right? Everybody is different, and I like to play all types of games. So if I have a crowd that doesn't really play games, I like The Mind. It's very simple. It's easy to play. Anybody can learn it. If I'm playing with hardcore gamers, I'll play something like Rolling Stock. Very economic, very crunchy.
Yeah. Have you played Acquire? I'm a massive board game nerd.
Oh, you are? Okay, yeah. I have played Acquire.
Yeah.
But it's not part of my regular play.
Yeah. My current favorite right now is Dune Imperium.
Okay. I've heard about that. I haven't played it yet.
It's great. You definitely gotta have people that enjoy deeper board games because you're talking like minimum 3-4 hour commitment.
My favorite game 10 years ago was a game called Twilight Imperium. And that would take all day. Yeah.
Oh, yeah. 12, 13 hours.
Yep.
Typically, my partner for his birthday, that's the only way we can like wrangle our friends that can do deeper games into it. I'm like,
Right.
It's a birthday celebration. We're starting at 9:30.
Exactly right. Yeah. I've had many birthday parties playing TI3 all day.
Wow. All right. Programming, like tabs or spaces?
Oh, spaces, of course.
Great. Okay. So one final question. Where can listeners find you and be helpful to you?
If you want to find me, I'm on the Typico Data Slack. It's typicodata.com/Slack. I also have an Instagram, but that's mostly like jujitsu and bread. So I don't know if you want to follow me there.
Wow, this is super fun. Toby, thank you so much for being on the podcast.
All right, thanks for having me.
That's all we have time for today. If you're interested in being a guest on the show, or if you'd like to suggest a topic, find us on datarenegades.com. Data Renegades is brought to you by Heavybit, the leading investor in enterprise infrastructure. For more information, visit heavybit.com.